you know how to do. So up top,
Yeah, I got your zoom.
zoom in, zoom out. All right, so chapter 14. Don't mess around.
I already showed my face. Might have to restart.
Okay, so chapter 14 is on vibrations and waves. So with vibration waves, you know, we're going to have this thing called periodic motion. Now, what do you think periodic motion is?
Motion over a period of time.
Okay, or
Like sideways?
motion that has a cycle. Repeats the cycle. Okay, so where have we kind of seen this before?
The Earth
What about the Earth?
revolution.
Well, that is a periodic motion, yes. But kind of thinking more, you know, if we're talking about vibrations and waves, where have we kind of seen periodic motion with that?
Ocean.
The ocean, okay? Or you play a string instrument, particularly like a guitar or something like that, and you pluck the string, you know, you see the string up, down, up, and down, up, and down. And eventually, it will stop. Now, once that string stops, it's at equilibrium, because all the forces that are acting upon it are the same. All right? All right, so periodic motion does have a period. What a period is time needed for an object to complete. I hate how this thing just bounces. One cycle. Now, for this chapter, since period is going to be time, we're going to represent it with a capital T.
Sweet.
All right, now, one other thing. Amplitude. Remember what amplitude is?
It's like the distance between, what, the very top and very bottom, or is it just the middle and the bottom?
It's like, yeah, that was the equilibrium in the.
Maximum distance away from the equilibrium. So for, you know, if we're kind of looking at a wave, it'll be the distance from point zero to the crest or to the trough,
Right.
all right? Now, the first thing that we're gonna kind of do, we're gonna kind of break up this video a little bit, so it's gonna be like 2 small videos and everything like that, because we're gonna do a mini lab here in just a little bit. We're gonna be dealing with springs. Now, with springs, some of them follow Hooke's law. Okay, what Hooke's law is, force exerted by a spring is equal to the spring constant times the distance, excuse me, the spring moves from equilibrium. All right, so formula for Hooke's law. F is equal to negative kx. K is the spring constant. X is the distance. The spring constant can change because it kind of depends upon how stiff that spring is. Okay, so it's not going to be an actual set number. It's going to change for even from spring to spring. Okay, distance, we can find that. Not a problem. Now we can also determine how much potential energy the spring has when it's away from equilibrium. Alright, so the way that we find the potential energy of the spring is we take the formula 1/2 kx squared. So we're going to do a little demo real quickly, dealing with Hooke's law and also with potential energy. So I'm going to go ahead and stop recording.